Alright, this video is for lesson 72. We're going to start with part A, and we're on page 292 of your textbook. This first part is factors that are sums. So sometimes a trinomial has a common factor that is a sum. So the first example they give you is, we've got parentheses and it says a plus b times x squared minus a plus b times x minus 6 times a plus b. So first we have to factor out the common factor, and we'll notice that the common factor is a plus b. That's in all three of these terms. So we're just going to pull a plus b out, and then we're left with x squared minus x minus 6. Now we can factor this trinomial right here. So we got a plus b, and then we're going to put our two parentheses. And the first parentheses, the beginning term on both of those is going to be x, because x times x is x squared. Now we need something that multiplies to negative 6 and adds to negative 1, and that would be 6 times 1, and we need it to be, no, that would be 3 times 2. 3 times 2, and we need this one to be negative and that one to be positive. 3 times 2 is 6. Negative 3 and positive 2 would be negative 1. Alright, that's the first example. These are just like you've been doing on factoring trinomials, except they're going to look more confusing because they'll have that addition in there, and you just have to factor that out first. Alright, so another one says x plus y times x squared plus 9x times x plus y plus 20 times x plus y. And if we look, we'll see that x plus y is in each one of these. We're going to pull it out first. And then we're left with x squared plus 9x. And that's supposed to be 20 plus 20. Alright, and that one is going to be x plus y, and then we're going to write our two parentheses. And we've got x times x makes x squared. And that one's going to factor out to 5 and 4. 5 times 4 is 20. 5 plus 4 is 9. Alright, I'll do one more example. This one is m times x minus 1 times x squared. And then we've got plus 7m x times x minus 1. And then we've got 10m times x minus 1. Okay, on this one we have more than one factor to factor out. We've got the x minus 1 on all of those. And then we've also got m on all of those. So we're going to do m times x minus 1. And then we're going to see what we got left. So if we got rid of the m and the x minus 1, we'd have x squared for that first term. And this one we've got rid of the m and the x minus 1, so we've got plus 7x left. And this one we got rid of the m and the x minus 1, and we're just left with plus 10. Now we can factor that because it's a trinomial. And then we put our two parentheses right here, and we're just going to factor like normal. So x times x is x squared. And then we need two numbers that multiply together to get 10 and add together to get 7. That will be 5 times 2. And they're both addition. They're both positive. 5 times 2 is 10. 5 plus 2 is 7. Alright. Okay, this is lesson 72, part B, and this is going to be pyramids and cones. A pyramid is a geometric solid with one face or polygon called the base, and the other faces are triangles. They're called the lateral faces. So if we have a pyramid, let's just do a square one. So we've got a square. And then each of these faces is a triangle right there. So we would have 4 faces that are all triangles and a square base. What they're going to ask you to do is find the volume of that. First, there's a couple of terms that we want to know. The point where all those triangles meet, right here at the very top, that's called the vertex. And then the slant height is defined for regular pyramids. The slant height is going to be the height from here to here, how slanty it is. And then a right angle coming straight down from the base straight down from the vertex to the base at a right angle is going to be called the axis. That's in the center. And that is also called the altitude. So the distance from here to here is the altitude. And that's called the axis, is what's going straight down the center from the vertex to the base. And the measure of that axis is called your altitude. Alright, so sometimes you might have a cone. This is a slanty cone. These are hard to draw. Alright, so we've got a circle on the bottom. We got our cone coming up. And then our vertex would be here. And then we would have the axis would be a straight line from the vertex to the center. It's going to be our axis. And then the height from the vertex to the base, right here, would be the altitude. Alright, so altitude is going to be your height from your base to your vertex. Your axis is a straight line that goes from the vertex to the center of the base. And your vertex is where all of your stuff meets at the top. It's your pointy part at the top. There's one more that you would need to know for a cone. So we've got our circle and our cones going up. And that's going to be your slant height. And it goes from here to here. So how far is it from there to there on this surface? And that's your slant height. And for some reason, they label that as L. Little squiggly L. Alright, volume of pyramids and cones. The volume of a pyramid or a cone is equal to 1/3 the area of the base times the height. So it's just a simple formula. 1/3 area of the base times the height. Alright, so let's say that we have a pyramid, and I am looking at the example on page 294. Please open your books to that page because you can see that their drawing looks a lot better than mine. And it says that your height right here, your altitude, is going to be 8 inches. And then we've got 9 inches right there. And that one is 7 inches. So, all we have to do is 1/3 times the area of the base times the height. The area of the base would be 9 times 7, which would be 63. And then the height would be 8 inches. So we have 63 times 8 times 1/3. And then we just multiply that out with a calculator. So 63 times 8. And if you're on a calculator and you don't know how to do times 1/3, that really just means divided by 3. And that is 168. Alright, so volume's pretty easy, and feel free to go back to this page and look at that formula again as many times as you need to when you come to those problems until you would just remember it on your own. Alright, the next part is surface area of pyramids. So, surface area is going to be the area of all the faces. The lateral surface area of the pyramid is going to be all the faces except for the base. Find the surface area of this regular square pyramid. So for surface area, that's got a regular square pyramid, so we've got a square at the base. And then we've got 4 triangles all connected together coming to a point right here. And it says that this is 6. So if this one's 6, then this one's 6, then that one's 6, then that one's 6, then it means its height is 6 as well. And we are supposed to find the surface area. So for the base, it's going to be a square, so 6 times 6 is 36. So our base will be 36. And then we've got 4 triangles. Now the triangles look like this. And it says that it's going to be 6 right here across the bottom. Alright, so we have to figure out how tall that would be. And it tells us that it also has on the drawing that this is 5 right there. So if this is 5 tall, the area of a triangle is the base times the height divided by 2. So 6 times 5 is 30. Divide that by 2, you would have 15. So the area of one triangle is 15, and we have 4 triangles. So 15 times 4, which would be 60. And then we just add that to the base, and we get 96 centimeters squared. So on those, you're going to have to figure out the area of each of the triangles and add that to the area of the base. For a cone, the lateral surface area of a cone is a curved surface between the vertex and the base. We define the lateral surface area of a cone to be the area of the lateral surface. There's no simple way of computing the lateral surface area of a cone unless it is a right circular cone. A lateral surface area of a right circular cone is the product of pi, the radius of the circle, and the slant height. So I'm on page 296. So here's their example. We've got a cone, and its slant height, L, is right there, and its actual height is going to be right there on that dotted line. And then we would have to have the radius coming out, R, right there. So if we had a base with a radius of 9 and a height of 15, and let's see, nope, the slant height is 15, and the height would be we need to know the right circular cone has a radius of 8 and a slant height of 10. Alright, we're going to do that one up there. Radius of 8, slant height of 10. So what we're going to do is pi r squared plus pi rl. So pi r squared plus pi rl. Pi r squared is going to get us this, and then we do pi rl is going to get us the surface area, the lateral surface area, the curvy part. Alright, so that would be 3.14 times the radius squared. Radius is 8. 8 times 8 is 64. Plus 3.14 times the radius, which is 8, times L, which is 10. So that would be 80. And I'm going to multiply all this out using a calculator. So 3.14 times 64. And that's 200.96. Plus 3.14 times 80. 251.2, and then we just add those two together. We should get 452.16. So that's the example on page 296. So pause the video and try to do the practice problems, and then I will come back and do them. Alright, so hopefully you guys paused the video and you did the practice problems. Now I'm going to do those for you. And we're on 296, and this is lesson 72. Alright, so practice A is A plus B times x squared plus 8x times a plus b times 15, plus 15 times a plus b. First thing we got to do is notice that we have common factors of a plus b on all of these, so we're going to pull that out, a plus b. And then we're going to be left with x squared plus 8x plus 15. Then we just have to factor that trinomial, a plus b. And then we'll draw two parentheses. And our first term in both of these is going to be x, because x times x is x squared. And then we need numbers that multiply to get 15 and add to get 8. And that will be 3 times 5. 3 times 5 is 15. 3 plus 5 is 8. Alright. B. B has m minus b times x squared c minus 2x c times m minus b minus 24 c times m minus b. Alright, so we got a couple of like terms here that we can pull out, so a couple of common factors. M minus b, we're going to pull that out. Actually, let's pull out, and we also have c in all these, so we're going to put the c first. Then we're going to put m minus b. Now what are we left with? Right here we've got x squared. And right here we've got minus 2x. And here we got minus 24. Okay. So now we just have to factor our trinomial. So we could put our c times m minus b. And then we're going to put two parentheses for our trinomial. And we go, no, x comes first because x times x is x squared. And then something that multiplies to 24 and then adds to negative 2. 6 times 4 is 24, and it would need to be negative 6 and positive 2. 6 times 4 is 24, and then negative 6 and positive 4 would be negative 2. Alright, so this is C. C says find the volume of this right rectangular pyramid. It's got a base of 8 by 10 and a height of 12. So to find the volume of a rectangular pyramid, we're going to do 1/3 times the area of the base times the height. Alright, area of the base would be, it's 8 by 10, so 8 times 10 is 80. So we got 1/3 times 80 times the height, which is 12. 80 times 12, use my calculator, is 960. So it's 1/3 times 960. Now remember, 1/3 just means divided by 3. And we should get 320. And that's centimeters cubed because it's volume. Volume's always cubed. Alright, last one is D. D says a right circular cone has a base of radius 9 meters and a slant height of 15 meters as shown. Find the surface area of the right circular cone. Alright, so we're going to have to do pi r squared plus pi r l. Okay, r is going to be our radius, l is going to be our slant height. So it's going to be pi, radius is 9, plus pi, radius is 9 again, and l is 15. Alright, 9 squared, 9 times 9 is 81, so pi times 81. I'll do that real quick on my calculator. 81 times 3.14 equals 254.34. Now I need to add that to 9 times 15, pi times 9 times 15, 135. Okay. Now we're going to do pi times 135. And that is 423.9. And then the last step is to just add those two together. And that should be 678.24. And that's meters squared, because this is area, not volume. All right.